Hey everyone! Welcome back to ZoomInData. And this is episode 33 of our KQL Concepts Deep Dive series. Today we are pulling it all together with KQL best practices and anti-patterns, the do's and don'ts that make queries fast, cheap, readable, and production ready. We are keeping everything pure concepts and interview focused. This episode builds on everything we've covered so far. Let's wrap up with real-world wisdom. Here is our roadmap for today. We will cover performance best practices, filter early, project only needed columns, use materialize for repeated subqueries. Then anti-patterns, full table scans, late filtering, dynamic column overuse, skipping hints when stats mislead. Maintainability tips. Write readable queries, use named expressions with let, add comments, avoid magic numbers. Common mistakes. Summarize without bin for time data, joining without cardinality hints. Production tips. Monitor query cost and resources, use materialized views wisely, always test queries at realistic scale. This episode is about turning good queries into great ones. Let's dive in. Performance best practices. These are the golden rules that separate slow queries from blazing fast ones. Filter early. Push where clauses as far left as possible. Reduce rows before summarize, join, or MV expand. Project early. Select only the columns you actually need. Drop unnecessary data before heavy operations. Use materialize. Cache expensive subqueries or common sub-expressions used multiple times. Huge win for repeated patterns. Use hints. Cardinality hints on joins. Force broadcast or shuffle when stats mislead. Take control when needed. Prefer approximate functions. Approximately _ percentile. Decount. Top N with approximately. Tiny error for massive speed, memory savings at scale. Follow these religiously. Filter and project early. Materialize repeats. Hint smartly. Approximate when possible. And your queries stay efficient even on petabytes. Now the anti-patterns. These are the common mistakes that kill performance and maintainability. Anti-pattern 1. Late filtering. Summarize or join first, then where. Scans the entire dataset before dropping rows. Always filter early. Anti-pattern 2. Overusing dynamic. Keeping large dynamic columns through filters, joins, or summarizes, memory and speed suffer. Flatten early. Anti-pattern 3. No materialize on repeated subqueries. Recomputes the same expensive part multiple times, waste. Anti-pattern 4. Summarize without bin on time data. Irregular buckets make trends and anomalies unreliable. Anti-pattern 5. Joining large tables without hints. Optimizer picks broadcast when it should shuffle, memory explosion. Avoid these traps. They are the silent killers of production queries. Spot them in code reviews, fix them proactively. Look at this side by side. It highlights the biggest performance killers and their simple fixes in KQL. On the left, red warning icons flag the anti-patterns we must avoid. Late where. Filtering after summarize or join scans everything unnecessarily. Dynamic column. Carrying large dynamic objects through heavy operations eats memory and slows everything. No materialize. Recomputing expensive subqueries over and over wastes compute. No bin. Summarizing time data without bin creates irregular buckets that break trends and analysis. No hint. Letting the optimizer pick the wrong join flavor, broadcast on large tables, causes blowups. On the right, green check marks show the best practices that save the day. Filter early. Shrink rows before expensive steps. Flatten dynamic. Unpack to typed columns as soon as possible. Materialize. Cache repeated subqueries once. Bin time. Create regular intervals for clean time series work. Hint joins. Force broadcast or shuffle when you know better than the stats. The message is clear. Avoid the red traps that silently kill performance. Embrace the green habits that keep queries fast, cheap, and scalable. Spot these anti-patterns in code reviews, swap them for the green opposites, and your KQL becomes production grade, efficient, maintainable, and loved by your cluster. Maintainability best practices. Write queries that future you and your team can understand and modify. Use let statements extensively. Name subqueries, common expressions, constants. Makes logic reusable and readable. Add comments. Explain business intent, why certain filters or hints exist, what the query solves. Avoid magic numbers. Define thresholds and constants with let. High latency threshold equals 500 milliseconds, much clearer. Modularize complex queries. Break into named let steps. Easier to debug and reuse. Keep consistent style. Logical column order. Proper indentation. Meaningful aliases. Readable queries are maintainable queries. Invest in clarity, and debugging, onboarding, and evolution become painless. Production tips and common mistakes. Monitor query cost. Use. Show queries to track duration EMS, CPU EMS, data scanned, spot expensive patterns. Always test at scale. Run on full dataset or large sampled partition. Small tests lie. Use materialized views for truly frequent aggregates. Don't create one for every dashboard query. Common mistake 1. Over-relying on union asterisk without strong filtering. Scans every historical table unnecessarily. Common mistake 2. No project before summarize. Carries useless columns through aggregation. Wastes memory and time. Production mindset. Measure cost, test realistically, use mat views judiciously, filter aggressively, project early. These habits keep clusters happy and queries affordable. Look at this quick checklist. It's your go-to production sanity test for KQL queries. Green checks for the must-do habits. Monitor cost, track duration EMS, CPU EMS, data scanned in. Show queries. Spot expensive patterns fast. Test at scale. Never trust small sample results. Run on full or large partitions to catch real blowups. Mat views wisely. Use materialized views only for truly frequent aggregates. Don't create one for every dashboard. Red X's for the silent killers to avoid. Union asterisk no filter. Scans every historical table without pruning, massive waste and slow startup. No project before summarize, carries useless columns through aggregation, burns memory and time for nothing. Keep this checklist in mind. Green habits keep queries fast and clusters happy. Red anti-patterns quietly inflate costs and latency. Build the good habits, eliminate the bad ones, and your KQL stays performant, cost-effective, and production-ready every time. Why does this topic matter in interviews? Best practices and anti-patterns are a top topic for senior and production-focused roles. Common questions include, how do you optimize a slow KQL query? What are your top performance tips? Name common anti-patterns you see and how to fix them. Explaining filter early, project early, materialize repeats, hints when needed shows real production experience. It's critical for query tuning, cost management, and team collaboration roles. Demonstrating maturity, moving beyond syntax to real-world impact, maintainability, and cost awareness, sets you apart. If you can walk through, I always filter early, materialize common subqueries, monitor cost, and avoid late filtering, you sound like someone who owns production clusters, not just writes queries. To wrap up, performance, filter and project early, materialize repeated subqueries, hint when optimizer wrong, prefer approximate at scale. Avoid anti-patterns, late filtering, dynamic column overuse, no materialize, summarize without bin on time data. Maintainability, use let for naming, add comments, eliminate magic numbers, modularize complex logic. Production habits, monitor query cost, test at realistic scale, use materialized views judiciously. The mindset, write queries that are fast, cheap, readable, and maintainable, not just correct. These practices separate good KQL from great KQL, and make you the person teams trust to keep clusters healthy and costs low. That's episode 33 done. Thanks for spending time with me on ZoomInData. Next in episode 34, KQL in production, we will explore cost optimization, query monitoring, troubleshooting slow queries, and cluster health. Homework to lock this in. Explain to someone or out loud, why filter early in KQL queries? Think of an anti-pattern you've seen, or could imagine, and how to fix it. Answer this one. What are 3 ways to improve query maintainability? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 34, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.